Have you ever looked up at the night sky, at all those distant stars, and wondered how it's possible that our universe exists in such a delicate balance? The more scientists uncover, the clearer it becomes that everything from the speed of light to the strength of gravity to the way atoms hold together seems inexplicably fine-tuned for life. The universe's very structure appears to operate within a narrow range of conditions, each precisely calibrated. But why? Why should the cosmos be so perfect? It's a question that has haunted scientists, philosophers, and thinkers for centuries. How is it that the universe's fundamental forces are set just right, allowing galaxies to form, stars to shine, and life to emerge? Even the smallest change in any of these forces would result in a universe vastly different, perhaps lifeless. Some call this remarkable precision the Goldilocks principle because, like Goldilocks in the fairy tale, everything seems to be just right. But unlike a fairy tale, this perfection doesn't have a clear explanation. Well, explore the science, theories, and profound mysteries that may explain why the universe is so perfect. Start with a simple fact. If even one of the physical constants were slightly different, our entire universe could collapse or turn uninhabitable. For example, take the force of gravity. If gravity were just a bit weaker, stars wouldn't form, and there would be no planets, let alone life. But if it were stronger, stars would burn out too quickly. There'd be no stable environments for life to even think about emerging. The same goes for the electromagnetic force, the thing that holds atoms together. If it were just slightly weaker, electrons would fly away from nuclei, and we'd never have atoms, let alone molecules, or life. It's like every cosmic switch was flipped to the just right setting, creating what scientists call the Goldilocks zone for life. And this doesn't just apply to our planet's position around the sun, it's woven into the very fabric of the universe. Why is it that every physical constant appears to be fine-tuned for our existence? One explanation is known as the anthropic principle, which essentially says that the universe's conditions must be such that we're able to observe it. If conditions weren't perfect, we simply wouldn't be here to question them. In other words, the universe seems perfect to us because if it weren't, there wouldn't be anyone around to think it was perfect. But the anthropic principle isn't exactly satisfying. It doesn't explain why things are the way they are. Is it possible, then, that we're just incredibly lucky? Let's run with that idea. Imagine rolling a trillion-sided die. To get a universe that supports life, you'd need to roll a trillion sixes in a row. Possible? Technically? Probable? Not at all. And yet, here we are, looking at a universe that seems suspiciously well-suited to our existence. If we trace back far enough, everything in the universe seems to have started with the Big Bang, a single event, 13.8 billion years ago, that created all the matter and energy we see today. The Big Bang wasn't just an explosion of matter into space. It was an expansion of space itself, creating everything from scratch. But how did this chaotic burst of energy create a universe so well-balanced and perfect? One of the biggest mysteries is what happened in the first tiny fraction of a second after the Big Bang, a period known as cosmic inflation. During inflation, the universe expanded faster than the speed of light. This rapid expansion smoothed out any unevenness, setting the stage for galaxies, stars, and planets to form in a nice, orderly way. If inflation had been even a bit slower or faster, we wouldn't have the structure we see today. And yet, by some cosmic coincidence, it was just right. Even before inflation, scientists believed that the initial conditions of the universe were determined by quantum fluctuations, tiny, random changes at a subatomic level. Imagine a blank canvas where random splotches of paint start appearing. Over time, those splotches combine to form a coherent image. That's essentially what quantum fluctuations did for the universe. They created the seeds of all the galaxies, stars, and planets we see today. But quantum mechanics, with its randomness and unpredictability, seems like an odd foundation for a universe so orderly. How did randomness give rise to such precision? It's a question that scientists are still grappling with. Some say it's just a natural outcome of quantum laws. Others suggest there might be something deeper going on, something we don't yet understand. Here's where things get wild: the multiverse theory. According to this idea, our universe might be just one of an infinite number of universes, each with its own unique laws and constants. In some of these universes, gravity might be too strong, or atoms might not form at all. But in this universe, our universe, everything happened to align perfectly for life to exist. If the multiverse is real, it would explain why our universe seems so perfect. We just happen to live in the one that got the right settings. It's like winning the lottery. If enough people buy tickets, someone is bound to win, even if the odds are astronomical. We might just be the lucky winners of the cosmic lottery. But the multiverse theory comes with its own set of problems. For one, it's nearly impossible to test. We can't see or measure other universes, so the theory remains speculative. Still, it's an intriguing possibility, especially for those who find it hard to believe that our universe's perfection is merely a coincidence. Now let's talk about something that makes up most of the universe but is completely invisible: dark matter and dark energy. Combined, they make up about 95% of the universe, and yet we have almost no idea what they are. Dark matter doesn't emit light, so we can't see it, but we know it's there because of its gravitational effects on galaxies. Without dark matter, galaxies would fly apart. Dark energy, on the other hand, is a mysterious force that's causing the universe to expand at an accelerating rate. Why do these mysterious forces exist? And why are they in the exact right proportions to allow galaxies, stars, and planets to form? If there were too much dark energy, the universe would have expanded too quickly for galaxies to form. If there were too little, the universe would have collapsed back on itself. Once again, we see this eerie perfection. Dark matter and dark energy are just right for life to exist, even if we don't fully understand them. So where does life fit into all of this? Some scientists argue that life is the universe's way of observing itself. The conditions that allowed life to emerge on Earth are so rare that some believe we might be the only intelligent beings in the cosmos. But if the universe is so vast and life is such a powerful force, shouldn't we have encountered evidence of other civilizations by now? This brings us to the famous Fermi paradox. If intelligent life is common in the universe, where is everyone? Some speculate that life might be incredibly rare, a product of the unique conditions on Earth. Others suggest that civilizations might be out there but are choosing to stay hidden. Either way, life's existence adds yet another layer of mystery to the universe. And here's the real kicker: consciousness. How did the universe go from a ball of energy 13.8 billion years ago to a conscious being pondering its own existence? Scientists have no clear answer. Consciousness is one of the great mysteries, a phenomenon that we experience directly but struggle to explain scientifically. Some philosophers suggest that consciousness might be a fundamental property of the universe, like gravity or electromagnetism. Others believe it's a byproduct of evolution, a way for organisms to survive and adapt. But the question remains: why does the universe allow for conscious beings to exist at all? And why are we able to ask questions about the nature of reality? So, where is this perfect universe heading? According to current theories, the universe will keep expanding indefinitely, thanks to dark energy. Over billions of years, galaxies will drift apart, stars will burn out, and planets will freeze. Eventually, the universe will become a cold, dark, and empty place, a fate known as the heat death of the universe. But some scientists think there might be more twists in store. Perhaps dark energy will change over time, or new physical laws will emerge. We're far from understanding the full story. All we know is that the universe is full of surprises and mysteries, and every answer we find seems to lead to more questions. In the end, why is the universe so perfect? In the end, we may never know for sure, but maybe that's part of the beauty. The universe gives us just enough to keep us curious, to keep us asking questions. And in a way, that endless search for answers might be the most perfect thing about it. So, if you enjoyed this journey through the cosmos, don't forget to give us a thumbs up and share this video with fellow space enthusiasts. Your support helps us continue exploring the wonders of the universe. Be sure to subscribe to SPACEEFIED and hit that bell icon so you never miss an update on our latest discoveries.